Hey guys, here's your do now. Pause the video and try it on your own. Okay, number 1, the 5 manners of death. That's our homicide, suicide, natural, accidental, and undetermined. Number 2, what is the manner of death in the following? A man falls from a tree and dies. That's going to be accidental. A man is killed in a bar fight. That's going to be homicide. A woman dies of liver failure. That is our natural. Okay, the mechanism of death from a woman that dies following a brain injury sustained when a tree limb falls on her. That mechanism is going to be like cessation of brain function, or maybe bleeding if there was a lot of blood loss. Okay, so on Canvas there is an assignment, death scenarios worksheet. We had time in class to work on this, so pause the video and work on that. Okay, you should have completed this. We went over the answers in class. For case 1, the cause of death was heart attack, mechanism of death is heart failure, and natural is our manner of death. For number 2, cause is head trauma, brain injury for mechanism, and accidental for our manner. For case 3, cause of death is drug overdose, the mechanism is heart failure, and the manner of death is suicide. And number 4, case of causes, blunt force trauma, mechanism is brain injury or bleeding, and then the manner is homicide. So today we talked about time of death and how we can use information about the body and decomposition to figure out the time of death. Okay, so oftentimes a forensic investigation, time of death is important in providing insight to crime being investigated. So we can look at post-mortem or after death, the changes, because those changes are fairly predictable. And these changes have been studied and applied to the field of forensics. Okay, so how do forensic scientists know about post-mortem changes in the human body? That is where our forensic anthropologists come along, and they have studied the decomposition stages of the body as it decayed. An example of this is at the BodyFarm located at the University of Tennessee that studies decaying bodies. This was our first example of this type of research being done. And there's a video, the link is on Canvas that you can watch. Okay, so several factors that we use to determine time of death. This includes liver mortis, rigor mortis, alga mortis, stomach intestine contents, stages of decomposition, and entomology, or our insects. Okay, first we're going to talk about today is liver mortis. This means death color. Okay, as the body begins to decompose, blood seeps down through the tissue and settles in the lower parts of the body. Okay, and that's going to cause a purple color that's visible where the skin and the blood settles. This is known as lividity, that pooling of blood. So here we can see that liver mortis, lividity is going to occur on the bottom part of our corpse. This begins 2 hours after death and is permanent after 8. Okay, so it can tell us the position of the body within the first 8 hours. So an example is Susan Cape. She was found in a park in New York City. She was lying face down. However, liver mortis showed lividity on the dorsal or backside of the victim. So what did this tell us? This tells investigators that she was not originally face down because of the lividity on her back. That means she had to be laying on her back for at least 8 hours. Okay, the things that affect this is the ambient temperature. Ambient is the temperature around in the environment at the crime scene, so it impacts the time it takes for lividity to set in. Hot temperatures will make liver mortis occur faster, and cooler temperatures will occur slower. This is why it's important to take a temperature at the crime scenes. So here's an example of liver mortis. So this pattern here is showing that lividity occurred on the back of the individual, and this pattern is actually because they died on a park bench. So those little checker patterns is from the park bench. Okay, this next one. Here we know that the body was on its back when it was for at least 8 hours because the lividity was is on the back. Here we know that the individual was face down because lividity is on the front of the legs. These white areas are the pressure points where the legs were located, and we can kind of determine how the legs were positioned at the time. Here's an example. Sydney Green's husband made a 911 call to operators at 1 p.m. asking for them to send an ambulance to his home. Forensic scientists reported dark lividity on the victim's back, and the temperature of the home was 70 degrees Fahrenheit. He states that his wife was fine 1 hour prior when he left the house to run an errand. When he returned, she was dead. So what can we determine about this? So you might notice that the dark lividity, we know that dark lividity isn't going to occur until 8 hours after the body has died. So there's no way she was fine an hour ago. So that means there's something going on with his story, and we are going to be a little suspicious. Okay, this picture right here summarizes the times and colorations for our livor mortis. So no discoloration, body has been dead less than 2 hours. Light discoloration, we're going to have 2 to 4 hours after death, and a dark discoloration, 4 to 8. And those ranges are because of those temperature differences. Okay, the next thing we're going to talk about is rigor mortis. Have you seen something like this? This is showing rigor mortis in this cow, because it's showing that stiffness. Okay, so death stiffness is our rigor mortis because the muscles stiffen after death. It's temporary, and it can be used to determine time of death also. So rigor mortis starts within 2 hours after death. And that stiffness starts at the head and gradually works its way down to the legs. After 12 hours, it's at the most rigid state, and it's going to stay that way for another 12 hours and then gradually disappear. This is our timeline and information about rigor mortis. So if there's no rigor, that means the body is either less than 2 hours or more than 36 hours. Okay, after 2 hours, we have rigor just in the head and neck. If rigor is everywhere, it's probably around 12 hours. 13 to 24 is when rigor is disappearing. So if we have rigor in the legs but not head or neck, that means the individual probably died 24 to 26 hours ago, and then the stiffness will be gone around 24 to 36 hours. Okay, so rigor also depends on several factors. Ambient temperature is going to be a factor as well. Cold temperatures slow rigor down, and heat speeds it up. Weight can also be a factor, but not always. Clothing, illness, and sun exposure, these are all related to our temperature. So we can have an insulator that makes it us cool down, the body cool down faster, or have a cooler temperature or a warmer temperature. And so all of these are going to have the same effect as our ambient temperature. Okay, the last one we're going to talk about is algor mortis. This is the temperature loss after death. So when a person is alive, they maintain a constant temperature, and after they die, they no longer can generate heat, so it begins to cool down. So temperature in the corpse is taken from the liver, so we have an internal temperature. Normal body temperature is 98.6. So here's an example. So approximately 1 hour after death, the body begins to cool. So at first, say we have a person that dies at 3:15. At first, they're going to be 96.8. An hour later, we haven't cooled yet, so it's going to be 98.6 an hour later. 1 hour after that is when we start to cool down, so every hour afterwards, it's going to go down 1.4 degrees Fahrenheit. So at 3:15, we'll have 97.2 because we did 98.6 minus 1.4 to get 97.2 at 5:15. Okay, this is true for the first 12 hours where it goes down 1.4 degrees per hour. After that, it's going to slow down and cool down at 0.7 degrees Fahrenheit until the body reaches the ambient temperature or the same as the surroundings. Okay, so if a woman dies at 9 a.m. on Tuesday and it's found at 11 p.m. on Tuesday, what will be the approximate body temperature? So at 9 o'clock, we're going to start at 96. An hour later, it's still at 98.6, and then an hour later, it's still at 98.6. Then we're going to lose 1.4. So 1.4, we can put this in our calculator, 1.4 degrees every hour until we've reached 12 hours. So we've already gone 1 hour. So that means the next 11 hours, we're going to lose 1.4 degrees a day. Or an hour. So 1.4 times 11 is 15.4. So we know that in the next 11 hours, it's going to lose 15.4 degrees. So we'll do 98.6 minus our 15.4, and we get 83.2 degrees. Now, we're going to start losing temperature at 0.7 degrees. So we'll do 83.2 minus 0.7 to get our next temperature, which would be 82.5. Then we're going to subtract another 0.7, and we're at 81.8. Okay, that's how we could use algor mortis to determine the time of death. Okay, so this is also affected by environmental changes. These temperatures are estimates, and cooler environments will have the temperature of the body, it'll cool faster, so it'll lose heat faster than warmer environments. So this is an opposite effect where if it's colder, it's going to happen faster. Okay. Also, wind can be a factor as well and have heat loss occur faster. Okay, so this is a summary of what you need to do and turn in today. So we have our death scenarios worksheet that we did together in class that you need to turn in, as well as our ticket out the door, which is the liver, rigor, and algor mortis maze. Okay, bye guys.